Joe 508, how are you? It is Sunday afternoon, and it is July 12th. And so we're just going to get going. I'm going to go straight to the taskbar right here, just to remind you what's going on. You guys realize that this all comes at you kind of fast and hard, but you can do it, okay? Thanks in large part because of the team that we have together here. All right, we have Carly, we have Julia, and myself. All right, so we're going to get into the weekly assignments right here. But before we do that, I just want to let you know that we're really liking how creative and innovative you guys have been in terms of your mock journal paper. It gives you a good feel of how to do it, and which is pretty cool. And you guys will someday be reporting outcomes from your workplace, and this is a cool practice session on how to get it done. Do you understand that we also have coming up the midterm? Okay, so this is July 26th. That would be this coming Thursday. It's open for 24 hours. Okay, open book, open world. I would open up your browser multiple times, and you can just kind of go back and forth between the readings, the previous quizzes, and dive into the midterm. Don't worry about it. Just the best thing you can do is just kind of relax into this, and you're going to do just fine, okay? Because we don't want you to be stressed out, as you've kind of evidenced from this course. Okay, so that's it. And I'm going to go right into the weekly assignments. So we're going to finish up the kind of hardcore biology, and we're going to start our interventions, which is probably welcome news for you. But it's important that you understand the hardcore biology as well. So my first lecture is going to be taking all of our newfound knowledge about stress, and we're going to be applying it to the immune system. I'm sure you're very aware of this. Again, this is the announcement of the upcoming midterm. Okay, Thursday the 16th. Okay, so and then you'll see that the final exam is on the 30th. Okay, all right. So we're gonna go right into this concept of psychoneurimunology, and then the next lecture is about interventions, and the most important one being surrounding yourself with supportive people. Okay, it's the quality of the relationships, not the quantity, and that's what we're going to get into in this one. All right, let's go into psychoneurimunology. All right, so again, my lecture is going to go right in here. We go over a couple key concepts. So I've really reviewed everything in a way that would be very palatable. Okay, so you can easily consume the information through here. These are journal articles, and you just kind of read through them and sift through it and find out what it is you like. We do get to finish up with a kind of a statement by our favorite stress expert, Robert Sapolsky, and take notes on everything. And then we have a couple of really cool videos that I really want you guys to take the time to watch. This one is just about the Center for Psychoneuroimmunology at UCLA, in the breadth of this area of expertise, and especially in terms of biology and stress research, and then a really complete study. This one's a little bit longer, but it describes an analysis of stress's impact, and I'm going to on overall health, and I'm going to talk about that as well. Okay, as it relates to immune system too. Sorry. Okay, and then we give you a prompt. Okay, where from your newfound knowledge, okay, you're going to talk about chronic inflammatory conditions. Okay, made worse by stress. Okay, you can think about things like irritable bowel syndrome. Okay, autoimmune skin disorders, rheumatoid arthritis, multiple sclerosis, but even just getting the flu and not being able to kick it. Okay, and why is that happening? And why we have a situation at hand right now with COVID-19 where people that are severely stressed are really vulnerable as well. Okay. So then here's the prompt, and it gets into a discussion of you talk about the nervous system influences. We're going to talk about a yin and yang, the autonomic nervous system. Okay, one is adrenaline based, that's the sympathetic nervous system. The other is acetylcholine based. The adrenaline based one is highly activated during the fight or flight, and it causes an elevation of pro-inflammatory markers that can really be an indicator of poor health. Okay, so chronic inflammation is associated with cancer. Chronic inflammation is associated with diabetes and heart disease, and chronic inflammation is also associated with clinical depression. All right, so this is why this is super, super important. We can rest and digest in this pathway right here. And this is the whole basis of what's called vagus nerve stimulation, which is a really kind of new wave approach. It's, it's a little bit invasive because you have to go after the vagus nerve, but it's shown very promising results, and that's the basis of the extra credit you'll see at the very end that I'll go back to. Okay, awesome. So that's kind of an overview of the whole thing here. Again, I honed down this nervous system aspect, this automatic nervous system. Okay, I like to call it that. Um, the powers that be called it the autonomic, but the automatic means you don't have to consciously think about it. Okay, the adrenaline rush is the sympathetic nervous system. Okay, the fight or flight, and then the rest and digest system is the cholinergic pathway mediated by this vagus nerve, and it's the rest and digest, and it reduces a number of the bad things associated with stress, and it reduces inflammation. That's key to this week's module. Okay. All righty. So you can go through this, and what we'll do is we'll just quickly call up our friend right here. Okay. And and this is the research article. Okay. And what I'm going to do is going to blow it up a little bit here, and it's got a really compelling title. Okay. And this is a huge overview. Okay. It's super well done. It is complicated, but we'll just kind of get through it together. All right. So psychoneurimunology meets neuropsychopharmacology. Okay. So, I think as a modern society, there was just, an explosion of pharmacology. If we had to look at eras in terms of human societies, I would say that the end of the 20th century was just an explosion of pharmacology, and it really started in the 50s and it went all the way through. If we had to conceptualize, what is different about the 21st century, it's an explosion of social media, pocket-based electronics, all that. Okay, we continue to build upon the pharmacology, but what I'm getting to is that we rely too much on pharmacology, and this article really goes back that our first thing that we should be doing is monitoring our diet, monitoring our stress, getting rid of obesity, and by doing those kinds of things, then we're going to reduce inflammation that is the underlying cause of so many diseases, including depression. And it's very circular. Depression can cause obesity, okay? And depression is associated with inflammation. It just kind of goes hand in hand and spirals out of control, all right? So you read through the abstract here, okay? Sorry. And it talks about neuropsychiatric disorders like depression, okay, and they're getting increased information looking at biomarkers of inflammation and how they are correlated, okay. They're going to talk about these acute phase proteins, and I wish they would just speak in everyday vernacular, everyday English, something that you're probably pretty aware of. Even Oprah has a couple of articles on it. So the one acute phase protein that everybody looks at clinically, it's a common blood test. It's called C-reactive protein, or CRP, and you should have levels of CRP of 3 milligrams per liter or less. Okay, and the other one that's most important because it's a super high risk indicator for having blood clots and consequent to that heart attacks and strokes is fibrinogen. Again, these are produced by the liver, both of them, in response to having lots and lots of other inflammatory messengers in your body. We'll talk about that later. Okay. All right. So they talk a little bit about these inflammatory cytokines, and I described that for you. These are just messengers. Okay, messengers. Just like I can sit here and text you right now, and you get that message. Okay. Well, the immune system cells, they're constantly messaging each other with these inflammatory cytokines, and they basically jack each other up and get each other super active, so they can. The whole point is you want to go after bacteria, you want to go after a virus. Okay, come on, guys, and everybody's on board, and it becomes this crazy attack because that's what you want to do. Oftentimes, it overdoes it, and that's when you become septic. Okay, and that's the situation we're having right now with SARS-CoV-2 infections, the immune system attacking it and overdoing it. Okay, all these cytokines and that activate everybody and cause septic failure and organ failure. So a lot of the clinical trials that are being looked at are not only just the ability to get a vaccination, which would allow you to get rid of the virus before it multiplies too much, but if it is in that state where it has multiplied a lot, we can use drugs that will reduce the inflammatory response. Okay, so and these would be drugs that that block TNF alpha, block interleukin 6. These are common drugs. And there's trials for the Humira and Enbrel and the IL-6 antagonists, things like that. Okay. Alrighty, and then that's what they kind of talk through down here, and they talk about these cytokine pathways. So this cyclooxygenase pathway, it is biology, but it's a pathway you're always trying to reduce when you take Advil, okay? When you take ibuprofen, these common pain relievers that reduce local inflammation are going after this enzyme by reducing its activity, okay? It also can reduce a little bit of clot formation as well, so there's a risk of bleeding there. All right. This guy is a super important one that there is no clinical drug that you can use, but it's a great readout as a biologist. And this is basically the pit boss that goes down to the nucleus and says, we need a bunch of more cytokines. And so the nucleus starts, you basically take out your cookbook, okay, let's pretend this is a cookbook, and you go to this chapter and you read the recipe and make a bunch of more cytokines, small little proteins, and then your cell produces them, okay? And that's a readout of how active it is, the nucleus is during inflammation, all right? Okay. They talk about cell types, okay? And they talk about this linkage that I was talking about: stress, diet, obesity, leaky gut, okay? Inflammation down in your gut from eating really, having a really poor diet can cause problems. And there's lots and lots of research on that. And that's what you got to have. The key is a moderate diet, lots of veggies, lots of fiber, things like that, okay? Alrighty. If you don't, then all these conditions that we see right here can cause an imbalance between your protector and your inflammatory T cells. Okay, these are special immune system cells in your body. These are your lymphocytes, so they're very specific versus the traditional sentries that we have out there that are not lymphocytes. Okay, and so the whole point of this article is let's make links between all this so that we can maybe target, okay, the unique contributions to the immune system, to mental health, and to stress generation, because we know that mental health, specifically clinical depression, is a reason for having elevated stress hormones. Okay. All right, so they go through on this in there's lots of detail. I just want you to we're going to highlight each part real quickly. Okay, so we have a lot of attention paid to inflammation, like I said, for cardiovascular disease, diabetes, cancer, neurodegenerative disorders like Alzheimer's, Parkinson's, ALS. But what about neuropsych diseases like depression? And so the point of this is we need to add this to the list. Okay. And then they go through and they start looking at each individual part that is linked up here. All right, so we can still make the case that inflammation and depression are just intimately intertwined. All right, so patients with depression show increased biomarkers of inflammation. All right, so what are they? Again, the traditional biomarkers that I was talking about. Okay, are the phase proteins that are released by the liver in response to other inflammatory cytokines. All right, so they talk about these acute phase proteins, and you can ask your doctor tomorrow to do a CRP test on you. Okay. Fibrinogen is another test that is traditionally looked at for people that have a problem in terms of high risk for getting heart attacks and stroke. All right, so they go through this and they talk about the inflammatory cytokines. all right? Here's the CRP levels that I was talking about. Your cutoff is 3 milligrams per liter, all right? It's also a great measure for autoimmune disease when the immune system is overactive, all right? So a lot of you may find yourselves, you have irritable bowel syndrome. You had Sjogren's disease like Julia had, she's over there. Hi, Julie. And and she had a CRP level of 7.5, okay, which was an indication that things were out of whack, right? And it really helped in terms of the ultimate treatment that she received. Okay, so so this is just kind of linking all these cytokines to depression, right? So that is just correlational, right? So let's just do an experiment, right? So we can infuse some of these inflammatory cytokines and see if you can induce clinical depression, all right? And it does, it works. And so there are a number of different studies that we looked at this, and we being the scientific community. Interferon alpha is a cytokine that was commonly looked at, and it was found to induce clinical depression, right? We then look at stress, okay? And so there's kind of a quagmire here. So stress causes suppression of T cell function, okay? That makes you vulnerable to infection, hands down. So people that are stressed out get infections more often and they stay sick longer, okay? At the same time, there seems to be elevated inflammatory cytokines coming from other cell types, okay? So it's not such a disconnect. Plus, you're going to have a lot of inflammatory cytokines if you're sick more often and you're sick and when you do get sick, you get to a deeper illness. So that's what this is all about right here. And they talk again about the measures that are made. Okay, we scroll down here and we can look at the effects on the brain. Okay, cytokines, they do get into the brain, especially under conditions of diabetes. If you have chronic inflammation from whatever disease you have, if you have an autoimmune disease, if you have chronic infections, that can cause a leaky permeability between your brain, right? So normally we have this thing called a blood-brain barrier that doesn't let these things in, but they do get in, okay, in people that are unhealthy, all right? Then what happens is if there are high levels of these cytokines, okay, it breaks down the barrier. That's what they're talking about right there, okay? So so they do get in, right? And then they cause a super activation of inflammation in the brain that can lead to destruction of brain areas. You know, it's a contributing factor to the loss of hippocampus and prefrontal cortex that we saw in stress. Okay, so here we see right here, we're talking about we see this the kind of baton is passed to inflammatory cells inside the brain, and the brain has their own special kind called astrocytes and microglia. They're kind of like immune systems, but they're just brain supportive cells that really clean up the debris and get rid of toxins. Okay, and we see, like I said, the prefrontal cortex. This is what makes us have decision making. This is what makes us manage our stress. Remember, when it shrinks, the amygdala gets bigger. All right, so inflammation does this. Okay, so these are all kind of intertwined, and it's a really cool way to think about it. All right. These cytokines also reduce the levels of dopamine, serotonin, and adrenaline in your brain, and these basically are volume control that make you feel good, right? And so what do we give antidepressants, okay? Selective serotonin reuptake inhibitors like Prozac, okay? That will, the whole goal is to elevate your brain serotonin, but here if you're in constant inflammation, your serotonin is going to be reduced, right? So they also bench it here in this first figure where yes, we have glucocorticoids at low levels, manageable, predictable stress, something that we'd like to do, like me surfing or you getting that up there on stage as an actor or an actress or whatever it is that you do for fun, where you can control your stress. And this causes a conversion of our inflammatory cells, you see them coming in here, into a good type, okay, that releases factors. This is called brain-derived neurotrophic factor that causes the brain to grow and prosper, because you do it in a controlled fashion intermittently, okay, versus chronic stress, okay? So this is again, going from the blood into the brain. Sadly, we're going from the blood into the brain this way on part B here. But here, the conversion has not happened. These are pro-inflammatory, and they're releasing this cytokine that is talked about in this paper called TNF alpha that is basically the target of Humira, okay, or Enbrel, where you're trying to take that out. So it causes activation of immune system cells that cause destruction of neurons, which is not a good thing. Okay, so this again talks about these cytokines. What are monoamines? Monoamines are my serotonin, which makes me feel good, makes me feel whole, makes me feel like I'm an integrated, happy member of my community. Okay, dopamine, okay, which makes me feel a rush of happiness and feels, it's basically pleasure is what dopamine's all about. And then adrenaline is the focus, okay? And so they talk about there's this what's called a negative relationship. The higher the levels of cytokines, the lower the levels of these transmitters. Okay. All righty. We're going to scroll down here. So another thing that happens is when you have an activated immune system, that's what this is right here. A macrophage is just this type of immune system cell that is your first level sentry, okay, that will eat up any bacteria or virus that it sees, okay. It responds to these messengers called cytokines, and it will convert tryptophan, which we use tryptophan to make serotonin, into this toxin called kynurenine, all right. So and this toxin then, which becomes kynurenic acid, reduces our level of dopamine. It causes cognitive dysfunction. It can also cause toxicity, oxidative stress, and degeneration through these mechanisms you don't need to know. But it's not a good thing. So you don't want to have a bunch of activated immune system cells. Okay. Awesome. So it goes through all this, and again, it starts getting pretty detail oriented in here. All right. And they talk about this right here, which is a cofactor for making all the neurotransmitters that are really good for us. The tyrosine that becomes dopamine, tryptophan, all that becomes serotonin. This NO is actually a good thing. All these things you need to have this cofactor, and you can increase it by taking your B vitamin supplements. Okay, and sadly, if you have too much stress in your life, it gets it to a point where you don't make these factors. And so they go through all this. Okay, all right. And then they go through the individual circuitry. This gets a little bit heavy, but I again read it as best you can. Okay, sources of peripheral inflammation and depression. All right, that's what this part is right here. We see right here we have this chronic inflammation. Okay, poor diet, early life stresses, psychosocial stress, which is happening right now incredibly because of this COVID-19 pandemic, but also people historically that are from lower socioeconomic groups are basically under chronic levels of social stress, and we saw that in the original Sapolsky documentary that you looked at. Okay, if you have a poor diet, you have a leaky gut. Okay, and the T cells. Okay, remember from cortisol and all these other factors can cause an activation of the inflammatory system that leads to cardiovascular disease, that leads to depression, cancer, and diabetes. Okay, so they're all really important factors. They're all interlinked. So then they go into diet and obesity. Okay, what we don't realize is the largest hormonal endocrine organ in our body is body fat. And when you become obese, then what happens is you start producing these hormones that run counter to health. Okay, they increase diabetes, they increase the risk of cancer. Okay, and also what happens is we have a lot of, especially tummy fat that we learned about. Okay, also called visceral fat, that the immune system invades it, and suddenly your round tummy visceral fat becomes its own inflammatory organ of its own, and it is kind of a predictor of really poor health. Okay, So they get into all this, then they talk about the leaky gut. I just want to go into this because there's a kind of a really cool figure in here, and they talk about the cytokines here. They talk about again this cofactor that you take. You can monitor with B vitamins. Okay, um, we know we can reduce our stress, and so these are all future targets that are being suggested, being researched. Hopefully, we'll go to clinical trial. Okay, we can improve our diet with monitoring diet, exercise. Okay, and reduce adiposity. Okay, all right, cool. So then I'm going to scroll down here, and they get into ultimately a description of that's the next article of the different forms of intervention. So again, here I just want you, I don't want to read all this for you, but you can kind of look at these things like meditation, yoga, tai chi, and how it affects this fight or flight response or rest and digest response. And that's what this is all about. They are right here talking about diet. Okay, so this kind of knowledge will serve you well when you design interventions for the different facilities that you guys will ultimately be running. Okay, so that's what that's all about. Okay. This one right here, I could click on it, but it's right here. All right. This is let me get out of that right there. Sorry. And I'm going to go on to the next one. All right. The inflammatory reflex. Okay. All right. So this again, this is a slightly thick article. Just I want you to do is just go through it and find out what you want. Okay. The inflammation is mediated by TNF. Okay. Tumor necrosis factor. This is the cytokine. Again, this is what we're targeting with Humira, Enbrel, things like that that reduce irritable bowel syndrome and inflammatory skin disorders and things like that. Okay. This describes them right here. All right. So we're just gonna continue on here. I want you to get down here. We see this. They start talking about the vagus nerve, and then when we get even lower here, they get into a description. So this would be vagus nerve stimulation, okay, that releases acetylcholine, that reduces this inflammatory cytokine. That's good. If you're in chronic pain, that increases inflammation, all right? And that's what these pain fibers are, substance P. Or if you're in chronic stress, you can have an elevation as seen right here, okay? All right, so that's one form where we have inflammation. Then we have the whole glucocorticoids and what they do, okay? So that's a different level of modulation. And then they get down here, and this is the figure I wanted to want you guys to take a look at. So again, it talks about this interaction between the brain and the immune system right here. All right. So we can stimulate the vagus nerve, and it releases acetylcholine so that it will reduce the inflammation. Okay. In addition, we have sensory fibers that are monitoring the level of the cytokines that are out there that will increase our level of stress. Okay, so we want to reduce it right here. Okay, ACTH also is a modulator. Okay, and this is remember the cortisol. All right, and then lastly, fight or flight and adrenaline right here. Now I like this figure because it shows you the potential. Okay, so we have psychoactive anti-inflammatory agents. Okay, so we have what is an NSAID, non-steroidal anti-inflammatory drug, ibuprofen, okay, things like that, Advil. There's a lot of other testable compounds that are coming up, and then we also have vagus nerve stimulation, which is an important mechanism on which you guys consider. In fact, when we look at things like conditioning feedback and meditation and acupuncture, it's because you are activating this part of the nervous system to reduce inflammation and disease. Okay. All right. Cool. So that's what that's all about. Just again, just sift through that and get to it as as easily as you can. Okay. Lastly, we have this really cool little article here, just a couple pages from our good friend. Who is it? Who wrote this thing? It would be Robert Sapolsky. Okay. And so he gets into this concept again, looking at his favorite model system, and that was the primates in Africa, where he's looking at dominance, social dominance hierarchies, okay, And he talks about glucocorticoids, but then he gets into inflammation over here. Okay, and he talks about how, again, this low social status can corrode your health. All right. So and high social status will promote your health. All right, and so we talked about it in terms of the stress response. He talks about it how the stress response then gets in there and impacts your immune system. All right, and is how your social status is a reflection of this. Okay, so again, sift through this. It's only a couple pages, and you're good to go. Awesome. All right, so then lastly, we'll come back over here, okay? So this is the Cousin Center, and I do indicate, guys, that we're providing the resources. Um, there are people that spend their whole lives to become experts in psychoneurimunology, and you guys are getting it in one lecture, all right? So I just want you to try and just get a true feel and flavor for all this, okay? This is a little 6-minute video. It's really cool. It talks about approaches and interventions, and then this particular video is interesting. It's a PowerPoint presentation by Professor Vedhara, but she focuses in on two components right here. She focuses in on um, I'll get myself out of the way here. Uh, Looking at the mind-body connection and vulnerability to influenza. Okay, we could think about the same thing right now. Okay, low socioeconomic status. Who is getting COVID-19? Okay, it's not the higher socioeconomic. On average, it's the lower socioeconomic status. People that are under chronic social stress. Okay, they're much more vulnerable to influenza. They're much more vulnerable to SARS-CoV-2, which is a different type of virus. We can look at progression of diseases, for example, who gets diabetes, and when they have diabetes, who gets foot ulcers. And she shows you this really, really amazing link between um, um, depression, psychological stress, and vulnerability to getting these diseases. Okay, awesome. Okay, very cool. All right, so that's it. So you go to the prompt, okay, and you will figure it out. I'm trying to escape out of my video, but it's not going to let me. But that's okay because I'm just going to go ahead and end my session with this. There she is. There's Julia. Awesome. She's love of my life. And you guys hang in there, and I'll see you next time.